Hi, welcome back, Introstat students. Today we are actually studying a new unit it's called Unit 4, Modeling Data Distribution. It's a short unit, all right, 37 topics. So today I would like to do quiz number 1, all right? Uh, okay, quiz number 1, let's go. 5 questions. Okay, so a school sells pizza slices at the concession stand during each sporting event. The school sells a mean of 200 slices per event with a standard deviation of 25 slices. The school um, the school spends $160 of fixed cost to buy the pizza before the event and earns a revenue of $2 per slices. They calculate their profit per event according to this formula. So total revenue means the total number of income minus total cost will be the profit. What will be the mean and standard deviation of the distribution of profit per event? All right, so they're asking you to find the mean. Um, okay, so we are given that so mean of profit. Okay, the mean of profit. So if you look at this formula, right, profit equals to total revenue minus total cost, which means the mean, which is this symbol, right? Mean of profit is the mean of total revenue, right? Total revenue minus the mean of the cost. So total revenue, the mean of total revenue. So the money all comes from the fact that, see, it says here earns a revenue of $2 per slices. And how many slices do they on average sell? 200. So $2 per slice, which means 2 times 200, we should be expecting a total revenue of 400. Now, what's the mean cost? It says here, right? Mean cost is $160, right? That's the fixed cost to buy the pizza, $160. So with 400 minus 160, they actually make a profit of $240. Right, $240. Let's see what the options are. Okay, so it's standard deviation. So there's two answers with mean of 240, 240. But we need to decide on what standard deviation. Is it 50 or is it 110? So now we found the mean, right? We found the mean. But now we're supposed to find the standard deviation. They say here that standard deviation, right, sells a mean standard deviation of 25 slices. 25 slices. Now, come up with this formula again. So, we need to use this idea that standard deviation, would the standard deviation change for the profit? So, we found the mean to be $240 of the profit, but would the standard deviation change? Right? With the standard deviation of the profit, what would that be? So total cost spends 160. Now that is fixed. and the revenue standard. So it seems like the standard deviation doesn't really change. It should be, what are the options? Let me see. So is it 50 standard deviation, or is it 110? And it's two per slices, $2 per slices. Now, interesting, because the standard deviation is 25, right? And we're multiplying each slice, right? There are 25 slices, and we're multiplying each slice by 2. So 25 times 2, our standard deviation for the profit should be $50. Okay? Okay. So Matthias ordered hydrogenous, well, kind of flower to decorate for a wedding. Apparently, that must be a very special type of flower for wedding. The stem plot gives the diameters in inches of the 35 heads of hydrogenous genus that arrive. So that's the distribution, right? The stem plot. So 7/7 is 7.7. So this 6 and the 0 will be 6.0 inches. This 6 and this 8 will be 6.8 inches. Which of the following is the closest estimate to the percentile, right? Percentile is tells us what percent of observations are less than or equals to a given value in the distribution. So this is what it means. So we're trying to find the percentile for the hydrenia head with a 5.2 inch diameter. Where is 5.2? So right here, that's 5.2, right? That's 5.2. And we want it to, let's box this up, 5.2, right? 5.2. Then we're going to count that and all the values below it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now, 13 out of how many altogether did we know? So it's 13 out of 35. So 13 out of 35, we need to find that. That's your percentile. 13 divided by 35, and we need to multiply that by 100%. That is 37, about 37 percentile, right? About 37 percentile. Okay, so consider the density curve. Now, this is called a density curve. You see that it is dotted here. That means um, it's like a, like a histogram, right? If you have, let's say, if you have a histogram with all the bars touching, and then if you roughly look at the shape, let's say if I change a different color, it's looks like this, right? So this is kind of the rough shape of the density curve. So in this case, the density curve, even though it's not curved, it's straight with straight lines. It represents the area, right? Density curve represents the area. So like the area here, they are all, if you add up all the area here, it should be 1. So density curve is like any other distribution, but with a shape. So here you look at, it looks like it's a trapezoid, right? From here to here to here. And this line is parallel to this line. And this is perpendicular to both lines. And this is a slanted line. Find the percent of area under the curve where x is more than 3. All right, more than 3. It's interesting. See, because more than 3 is this point to the right. So you're asking to find the area, right? The area, the percent of area. And the percent of area that is more than 3 is the whole entire density curve, right? It's the area under the whole entire density curve. which is 1, by the way, and 1 is equivalent to 100%. So here should be 100%. There you go. Right. By the way, if you ever need to find the area of a trapezoid, area of trapezoid, okay, which is half times the sum of parallel sides, which means you got to add this and this, right? The sum of parallel sides multiplied by the perpendicular height, which is this, right? The perpendicular height, right? Right there. Okay, that's the area of the trapezoid. So that's how you find um, the area under the curve. Okay, the grades on a geometry midterm at Springer are roughly symmetric with a mean of 73 and a standard deviation of 3. Now, I need to tell you that when they say something like this, when it's symmetric, so if you look at this is slightly symmetric. How would you put the mean? The mean is 73, right? And and the standard deviation. So typically it's 3 standard deviation to the right and 3 standard deviation to the left. And if it's standard deviation which is 3, so the next one standard deviation over it should be 76, one standard deviation which is 79, one standard deviation will be 82. So one standard deviation less, this will be 70, one standard deviation less, 67, one standard deviation less, 64, right? So roughly this is how it's going to look like. So Mayama scored 72 on the exam, and find the z-score for this. Now, z-score formula is none other than this, right? Z-score has a formula. You take the data, minus away the mean, and divide it by SD, the standard deviation. So the symbol looks like this: x, which is the data, minus the mean, which is this one, divided by standard deviation, which is this one. So take a look. X, which is the value here, 72, minus the mean is 73, divided by standard deviation, which is 3. So let's do the math here. Oh, I need to reword this and change this to always in front. And then, okay, so let's do this. We take 72 minus 73, whatever you get, -1, divided by 3 in the denominator. So we're supposed to round to the nearest 2 decimal places. So negative 0.33. Negative 0.33, 2 decimal places. Okay, let's do the last one. Consider the density curve. Yeah, see? Density curve is from here to here, from 2 to 7. And the thing we understand about density curve is that the area under the curve will always add up to 1. Okay? The area under the curve, area under the curve, right? In this case, even though it's a straight line, it's considered a curve. Area under the curve is always 1. So they ask us to find the height. What is this? What is the height here? Right? I want to draw a question mark, but not very good at it. So they ask us for the height, right? For the height here. What is the height? Now, we don't know what the height is. It's okay. That's what we want to find. But we know the width. From here to here is what? 5, right? 1, 2, 3, 4, 5, or 7 minus 2. That is 5. And when you multiply that area under the curve, should add up to 1, right? Should be 1, 0. So if you divide by 5 on both sides, because we want to get rid of the 5, we want to find h, right? Using some algebra. 1 divided by 5 is 0.2, right? It's 0.2. So the height there Here it should be 0.2. So hopefully this makes sense. Let me know if you have any questions. Thank you very much.